All right, guys, now we have made sure that we have performed all these steps mentioned here. We have created the virtual network, the firewall is deployed, virtual machines are all created, Windows, Linux. We have to make sure now the flow of the traffic is configured properly. At the end of the day, like I said, we want to make sure that all the traffic from these servers that we've created earlier will go through the firewall. That's the ultimate goal. Both inbound and outbound traffic should go through the firewall itself. Right now, with the default configuration, all of them will go through the virtual router, the routing in Azure itself, within the Azure. We don't want that. We want to control the whole traffic. So in this case, if you look at the diagram, let me show it to you. Right now, if this Windows 10 VM that we've created wants to access something on the internet, the way it works is like this. HTTPS google.com, the traffic comes here to the default gateway. This is the default gateway, the IP address, right? And after it reaches that gateway, since it's within the Azure network itself, it's going to route the traffic through the Azure network to the internet. Like somewhere here, or anywhere else, I don't know. But that's not what we want. We want to make sure that we are forcing the traffic that's coming through from the servers to the firewall, not Azure network, okay? That's the ultimate goal. And we can do that by configuring something called route tables in Azure, all right? That's the whole purpose of route tables in Azure, to help us create some routing policies and all of that static routing to manipulate the way the traffic works within Azure. And we are going to do that together in this part. And the objective is for the internal traffic for the DMZ network to send all the traffic through the firewall if it wants to access the internet, and any traffic that comes from the internet, we want to make sure that it all goes through the firewall itself and all the way down to DMZ and to the servers. We don't want the traffic from the internet be something like that, like to the internet, to Azure network, Azure WAN, and bypass the whole firewall and reaches out to these servers directly. We don't want that. Now let's do this together. The way we are going to do that is we go to Microsoft Portal again. All right. You can do it both ways. You can search route table. I think it's easier to do this. Just click on route tables. As you can see, we don't have any route tables here. Back in the old day, the firewalls, when we were deploying the firewalls, it would have done this automatically. I'm not sure why it's not happening right now. It's okay. We are going to do it manually, actually. So click on create route table. Okay, resource group within the same resource group, which is great. I'm going to call this route table DMZ route table. Easier to understand. Propagate gateway routes. Yes. Click next. Review and create. All done. Create. The route table is created. Now we have to configure it, right? Doesn't happen by itself. So let's give it some time. All done. Deployment is complete. Now I want to go to the resource itself. Click on route table. As you can see, we don't have any routes here. No subnet that are associated with this routes. So let's do that together. And the way it's going to get done, I'm going to check. I think it's configuration. Okay, routes. I'm going to click add. And want to make the name in a way that's easy to understand. Okay. So if I'm creating a route table for DMZ, first of all, I'm going to click on to internet. Destination type IP addresses. I'm going to type in 000/0. That's the whole internet, guys. If you don't know what that is, what that means, go back to your Network Plus study or CCNA. I don't know. Learn about networking. It's all about networking in this course. Next hop type. I'm going to type in, I think it should be virtual network, but it doesn't allow me to type in the next hop IP address. Okay, virtual appliance. Yes, exactly. We want to send all the traffic to a virtual appliance, in this case, a firewall. So what's the IP address that we've configured? 10.10.200.4. Let's double check that together. We want to be sure. I'm logged into the firewall. Click interface. The DMZ port interface is 10.10.200.4. Awesome. So the next hop IP address to 10.10.200.4. Let's double check 10.10.200.4. Awesome. So let's add it. All done. So what I'm actually doing is to create some routes here in the routing table. In this case, in this network, within this network, I'm telling that anyone that resides within this subnet DMZ, if they want to reach the internet 0000/0, the next hop, the next gateway is the firewall. Okay, that's the whole purpose. I'm now going to add another route telling if you want to, like if these servers want to access anything that's here, like on the WAN side, it also needs to go through the VM. But I don't think we need to do that. Don't do it. We'll see how it goes. I think that 000 route is enough. So all done. Let's go back to the configuration again, overview. So as you can see, when you click on the overview, it's going to show you the new route that has been created here. Awesome. But this route has not been associated with any subnet. We want to associate this specific route to a subnet. So click on subnet and click associate. Cybernet, that's the network, virtual network. I'm targeting CYDMZ specifically. All done. Cool, perfect. This is done. Let's have a look. Overview again. Okay, perfect. Now it's configured, it's applied. Now the next step is to do the same thing, but for the other side. Traffic coming from internet that wants to reach to the DMZ network. Okay. We have done the internal part, the DMZ part right now, here, this part, but we haven't done the other way around. We want to make sure that all the traffic that's coming from the internet to our Azure network destined to these servers, the public IP address of these servers, will go through the firewall and back to this network. So let's do that now. For that, we have to again create another route table. Don't do the same thing in all, like in the same route table. We need to have a separate route table. Go back to route table again. Let's create another one. Create. I'm going to call this CY WAN route table. I don't know, anything that comes to your mind, guys. Doesn't matter. No need to tag. Next review. I'm going to click on create. It's a straightforward process, not going to take that long. Awesome. Go to resource. Again, we don't have any routes here. I'm going to do the same thing, but from different perspective. So going to create a new ad. I'm going to call the route here to DMZ in this case. Destination IP addresses. What's the DMZ? 10.10.200.0. 10.10. Oh, sorry guys, 10.10.200.0/24. Okay. The next hop is not virtual appliance, virtual network actually. I'm going to choose virtual appliance again in this case because it doesn't allow me to choose the next hop. Oh yeah, exactly. It should be a virtual appliance. I forget it every time. So that's the whole purpose. Any traffic that comes through here, I want to make sure that the traffic goes through the external facing interface of the firewall. In this case, 10.10.04. Let's double check together. Ten 10.04. Perfect. That's the WAN interface of the firewall. 10.10.0.4. Double check. 10.10.0.4. Awesome. Add. So far so good, guys. Now we have to associate this route table, like this route, to a subnet. Associate. In this case, guess what? We are not going to associate it to DMZ. We are going to associate it to a WAN subnet. In this case, this subnet here on the external side. Hope that makes sense, guys. If it doesn't, reach out to me. I'm happy to provide more guidance on this. Click OK. Let's give it some time. Awesome, cool. Click on overview, refresh. Nice, nice. I can see all the configuration here, which is great. Now that we have configured all the things here, I mean, at the end of the day, we want to make sure it's all configured properly. We need to validate and verify the connectivity. Okay, so what we're going to do together here now, I'm going to log into this what it's called, the Windows 10 VM here in this case, and I want to generate some ping traffic to the internet. I want to see the logs here on this firewall because the whole purpose was to make sure that traffic goes through the firewall. So I have to see and validate that in that case. On top of that, after that, we are going to expose these machines to the internet, and I'm going to actually use my current Windows machine to access, let's say, RDP to this Windows machine in this case through the firewall. All right. Now let's do this together. What I want to do, I'm going to access the resource group. We're going to go to the lab relevant resource group. In this case, I'm looking for the Windows machine, VM Windows. All right, perfect. So like I said, we don't have any public IP address. We have to use the Bastion service. So as you can see, Bastion service is succeeded. All we have to do is to just type in the username and password and access this machine from the portal itself. Let's see. Oh, pop-up blocker. You have to make sure that it's always allowed. Let's do it again. Allow. Woohoo! Awesome. Feels good. You see, that's how to deploy a VM in the cloud in a secure way. You don't want to allow RDP to everyone on the internet. That's not good. I'm going to pause this video, guys. Alright guys, as you can see, the Windows is on. I've been able to access this machine through Bastion. Everything looks good, but let's see if we have the access to the internet and all of that. Double check if anything works or not. First of all, I want to make sure that I can connect to the Linux machine at the same time. So I don't remember the IP address of the Linux, but let's see. What's the IP address? 10.10.200.6. Let's ping the machine from the Windows. 10.10.200.6. Awesome. I can ping the Linux machine. Now, it's all with troubleshooting, like all step-by-step plan, guys. So I was able to ping this Linux machine here. Awesome. Now I want to check my connectivity with the gateway, default gateway. 10.10.200.1. Let's check that one as well. Ping 10.10.200.1. That's not good. Not sure why is that. IP config 10.10.201. It should work, right? Maybe it doesn't respond to ICMP. Like that's maybe the nature of Azure. What I would do, I'm going to check the access to the firewall actually. This case, this interface down below 10.10.200.4. But before we do that, I want to make sure if the firewall actually allows ping traffic on the interface itself. So the way we are going to do that, going to the interface, DMZ port, double click. As you can see, ping is allowed. So hopefully I can get a response from the firewall. Let's check it together, guys. Finger crossed. 10.10.200. Yes! Great news. That's perfect. So we have confirmed the connectivity from the Windows machine to the firewall, right? Now I want to check the internet access. Where is it? What happened? Okay. Start without syncing, confirm and continue. Okay, confirm, start browsing. Google.com. It shouldn't work. Okay, that's great news. It's not working. You can verify it actually. You can go to the firewall, all right? And if you go to the log section, forward traffic, it should give us some details here. Okay, not showing any logs. In the FortiGate firewall, I mean, there are so many trainings out there that specifically talks about how to configure this firewall. We're not going through to the details of configuring the firewall. But if you go to the policy, this is actually where you can see all the policy. And as you can see, the implicit deny at the end of the firewall, it's not logging anything. That's why we are not able to see any logs there. So by default, firewalls in general, they deny everything by default. The implicit deny at the end blocks everything. As you can see, it's increasing the byte, 70k bytes, kilobyte. So we are going to actually allow ping traffic to the internet. So I'm going to tell DMZ, that's the rule name, the name of the firewall, to internet. Incoming interface is the DMZ port. Outgoing interface is the WAN, right? The source, I can choose any. In this case, it's not best practice, but we don't have time. I'm going to choose all. Destination again will be all the internet, but I want to only allow ping traffic. Okay. And also maybe DNS. That's it. The action is allowed. Leave everything else. Here you have to make sure the NAT is enabled. Because if you have a look at the firewall here, if you know about networking, when the Windows server trying to send the traffic to the internet, traffic comes here first, goes through firewall, firewall checks the rules. If it's allowed, it's going to allow the traffic, but there should be a NAT configured here, okay, to make sure the traffic is NATed to a public IP address. If you remember, this interface on the external hand of the firewall is actually mapped to a public IP in Azure, as you can see down below. This is the public IP address of the firewall. So when we do that, when we enable the NAT, it's going to translate all the private IP addresses here in the DMZ to a public IP address here. That allows the internet connectivity. If you don't know what I'm talking about, you have to go study NAT topic. If you don't know what NAT is, you're not fit for cybersecurity, period. Okay, enable NAT. I'm going to use the outgoing interface. As you can see, we have all the good stuff that we can enable further down the line, like IPS, web filter, DNS, like antivirus, and all of that. We don't want to focus on that. I'm going to log all the traffic in this case and making sure the policy is enabled. Click OK. So let's go back to the Windows machine. I want to ping Google. Voila, perfect. I can ping the Google. That's awesome. But still, you see, I cannot access the web, like the browser, because the firewall is blocking the traffic. Only ping is allowed. If you go back to your firewall logs, in this case, let's do it together, guys. Forward traffic should give us some details right now. Why is it not doing that? It's going to take some time, but let's give it a few seconds or minutes maybe. But you can see it's increasing. The bytes here on the firewall is increasing. So any DNS or ping traffic is accepted, it's natted, and it's logging the traffic actually. But I'm not sure why am I not seeing any. Let's change this to memory maybe. Now that we know that the outbound traffic from the VMs to the internet is working fine, we want to make sure that the inbound traffic to from the internet to the firewall is also working fine as well. So let's work on that part. But for that, we need to create some rules and also some NAT configuration to make that happen. And the way we are going to do that is to go to the firewall itself, to virtual IPs. I'm going to create a new virtual IPs. Just ignore, if you don't know what that means, just go ahead with the lab. We don't need to focus on this. It's actually it's a NAT configuration on a firewall. That's what virtual IP is. Okay. Mapping an external public IP address to a private IP address. So I'm going to call this Windows NAT RDP. Interface is going to be the WAN side. External IP address is the public IP address. Copy and paste it here. Map to IP address range. We don't want to map it to a range, just a single IP address, okay? What's the VM here? 10.10.200.5. That's the Windows machine. 10.10.200.5/32. Invalid IP address. Why is it? Okay, all good. We didn't have to apply the subnet mask. Port forwarding. I don't want to map the whole thing. I want to use port forwarding. If you don't know what that means, Google it. Port forwarding. External service is RDP I-39. Map to IPv4 port will be the same thing. Okay. Awesome. We have that configured there. Now I want to create another rule on the firewall that allows internet traffic, like any traffic that comes from the internet to this firewall, allow that traffic for anyone to RDP to this server. Okay, that's the whole objective now. Let's create a new rule. In this case, internet to Windows RDP. Just a name. You can name it anything that you want to. Incoming interface will be the WAN interface. Okay. Look at it from the perspective of the firewall. Incoming interface. The traffic is coming to me from the internet, from the WAN interface. I'm going to choose WAN. Outgoing, where the destination is, it's actually outgoing interface. I'm going to send the traffic to an outgoing interface. In this case, is the DMZ interface. Source will be all. Destination, in this case, I'm going to choose the virtual IP we created earlier. Make sense? Service, we don't want to allow everything, only RDP. Perfect, awesome. In this case, we don't need to enable NAT. We've already done the NAT configuration previous step. Disable it. Okay, I want to make sure all the traffic is being logged. Click OK. Awesome. But before we do that, let's see if we can get any. Okay, you guys see, I am now getting the logs. The DNS log that we have generated here. Like NS lookup. I can generate, let's say, google.com or any other services like yahoo.com. And you can see the ping. I'm doing the ping. It's all here. It's going to take some time for the logs to show up here, but this is good news. We're seeing everything on this firewall. So the source IP is the VM, destination is the Google, the traffic is accepted, all the rules, all good. Everything is looking good so far, guys. Okay, back to the other part. Now we want to check the RDP. Now I want to test RDP connection from my own computer at my own home to that VM within Azure. But I want to make sure that the traffic goes through the firewall, okay, not bypassing the firewall. So I'm going to copy and paste the public IP address. And in this case, paste it here. If it doesn't work, it means that something is not right. We have to fix it. And I feel something is not right here. We have to fix it and figure out what's going on. All right, guys, I figured out where I messed up. Apparently, I forgot to do 3 things. First off, we had to make sure that the Windows 10 firewall is disabled because it's enabled by default. The second, we had to go ahead and change the remote desktop settings to allow all kind of connections to this machine. So this checkbox, it should be disabled. You have to uncheck it in order for it to work. On top of that, when you're configuring the virtual IPs, the NAT configuration, if you remember, I used the public IP address here in this case. Apparently, we don't need to do that because firewall has no clue about the public IP. From the firewall perspective, the external IP address range is the external interface. Like it doesn't have anything and like any knowledge about the public IP address. So I changed the public IP address here in this case to 10.10.04, which is the external interface on the firewall. All right. After I made that changes, I tried RDP and I got the prompt. Good news for us. Happy time. So CyberXcel, going to type in the password, click OK. Awesome. You see, guys, I'm logged into the same device. Like the bastion that provides, it actually got exited out of that one, and I actually have the access to the VM through RDP session. Great news, right? Awesome. So let's summarize. We created our portal, the access, subscription, and all of that. We created virtual networks, subnets. We deployed the firewall together. We made sure that the outbound and inbound access works fine. We configured the NAT policy, the rules. We created virtual machines here. Linux, Windows machine, all of that is created. Good news, right? Now the second part of the training series is, I think we don't need to do any initial configuration of the firewall. It's going to take so long. What I'm going to do right now is actually enabling the IPS and do some brute force attacks and do some scanning using Mmap and all of that to generate some alerts and activities. You know, when you enable the IPS, it's going to automatically detect those attacks from external threats and attackers. And we're going to do that together. All the connectivity is working fine. And after we do all of that, after we are sure that I'm getting some alerts from the IPS, the next stage is to connect this firewall to Sentinel, which will happen in the next part of the video series. So if you haven't subscribed to my channel yet, make sure to do that. click on the notification bell, like this video, share this video with everyone else that you know on social media. I don't ask anything in return. All I ask for you guys is to like this video, share it to everyone, so that way I can reach out to more people who are in the same situation like you, who are looking to break into the cybersecurity, but they don't have practical knowledge as like real world experience in cybersecurity. This is going to help them a lot, guys. So don't forget that. So with that being said, let's go ahead and continue with this training. I want to go ahead and enable IPS on this firewall. And the way we are going to do that is to go to security profile, intrusion prevention. There are some default policies here. We don't need that. Here in this case, I only care about two policies, brute force and maybe, I don't know, network scanning and all of that. All right. Create new. I'm going to call it Cyber Lab. In this case, botnet. I want to make sure botnet are blocked by default. Now you have to create IPS signature, specifically what kind of things you want to enable in your IPS. We don't want to enable everything at the same time because it's going to put heavy load on the device. That's not what we want to do. When you become a network security engineer, if you want to become a network security engineer, you have to make sure that the firewall is configured properly. In this lab, the whole purpose is to just create some real world alerts so you can perform incident response, SOC analysis, investigation, all of that in Sentinel, in a SIEM tool called Sentinel. That's not the whole purpose of this lab in this case. To teach you how to configure IPS. We don't want to do that right now. So the action I want to, I don't want to block it, to be honest. I want to monitor first, okay? Don't need to packet logging. I don't want to look at it like a Wireshark or any of that. I want to enable it. And filter is important. This is how you're actually going to tell the firewall what kind of things I need you to block or prevent. So in this case, the target is a server. It's not a client. Like from firewall perspective, clients are people who are accessing the internet or any of that, like client to a server. In this case, I want to monitor and protect this resource here, this Windows. In IT, in TCP/IP perspective, this is called a server. It's serving something. It's serving RDP. It's serving web traffic. If it's a web traffic or any of that, it's a server. All right. I'm going to choose server. And you will get like around 3,685 signature. I'm looking for only, let's say, brute force. FTP. It's not FTP. SSH, I want to add that definitely for the Linux machine actually. Remote desktops. Let's search a specific for brute force. I think we need to only use brute force. It's not HTTP or FTP. Okay, MS-RDP connection brute force. That's exactly what I'm looking for. So I added here. Just click on this. It's added. As you can see, it's now going to show it here. What's the detail? Edit. Action is passed. I don't want it to pass. Block. Okay. So guys, the new version is configured in a different way. So what you need to do is to click on create new action. I want to monitor it. I don't want to block any traffic right now because I'm trying to brute force my way into the to the RDP session. If I change the action to block, it's going to block it. First of all, we want to see if the IPS is even working, to monitor it first. Change it to monitor, packet logging, disabled, status enabled. In this case, I don't want to use the filter here. I want to only choose specific signatures. In this case, I'm looking for RDP now, RDP brute force. RDP connection brute force, I add selected, again add selected. So far we have added 2. I'm going to anything that's related with RDP. Do we have anything else? No, I don't think so. So these signatures are added and I want to make sure that it's monitoring, okay? We don't need to change the rate-based settings right now. So far 4 selected, click OK. Awesome. So these signatures are selected and it's in monitor mode. So what I'm going to do right now, let's see. And first, you have to make sure that the IPS policy is actually applied. Like this is just a profile. We created the profile. Now we have to go back to the relevant firewall policy that's allowing the traffic. As you can see, Internet to Windows RDP. I'm going to change this firewall rule and enable IPS feature on this one. So you have to go here and click IPS, change it the default to the one that we've created. What's the name? Where is it? Didn't we create that one? What happened? IPS, where are you? Wow, it wasn't saved. Apparently I didn't save it, unfortunately. So Cyber Lab. Man. Signature, monitor, status, RDP. RDP brute force. All RDP related are added here. Click OK. Click OK. It's added now. Cyber Lab. Let's go back to the firewall policy. Click Edit, enable IPS, and apply Cyber Lab. Perfect. Capture packets. We don't want that. I'm going to log everything. And that's okay. Click OK. Ignore that. Okay. I'm going to exit this RDP and try to brute force. I'm going to actually mimic the brute force, trying to enter the wrong username and password multiple times and see if it's triggering any alerts. Okay, the firewall should be able to detect the brute force, but the thing is, these IPS policies sometimes they are configured in a way to check the brute force that happens in a millisecond. Like maybe me trying to type in username and password is not that fast enough. Okay, sometimes the firewall is only looking for the attempts that are really fast, like in milliseconds. But let's see and try. Multiple time. I'm entering the wrong username and password. Let's do it faster. I'm doing it very fast as I can. Okay. My user has been locked, which is normal. That's expected. So let's see if the IPS was able to detect anything. Click on forward log. Let's have a look. Security events. Not that I can see anything here. So what's my IP address? Let's filter the traffic based on my IP. What is my IP? Okay, that's my IP address. So as you can see, I'm going to change the source to my IP address. Source. Didn't work. Why is that? Okay. It can see the RDP, but again, it was not able to detect the RDP because it's not enough, you know. It has to go more than that. It has to happen a lot more than the one that I tried. Let's do it multiple times with another user, admin. Let's do it multiple times. All right, guys. Apparently, the current RDP signature, the RDP connection brute force, the one that is created by default from the vendor, it's not that strong, so it's not very sensitive. So what we're going to do is actually create a new signature based on our own needs. Okay, completely from scratch. I actually have the configuration here. I'm going to paste it here in documents somewhere, so you guys can do the same thing. I'm just going to paste it here. But let's create a new signature together. So the way we are going to do that, apparently, like I said, the one that we have created here doesn't work. Now we have to create a custom based signature here. So I'm going to do that, create new. I'm going to name it cyber brute force. And I'm going to paste the signature. Hopefully it works. But the destination port on 3389. 3389. And the pattern is 5 packets within 5 within 20 seconds. Okay. Let's click OK. I'm going to now add this custom signature to the one that we created earlier. So you see, this is the custom signature here. It's not added here. Delete. Create new one. Signature only this. And I want to make sure the action is, I don't know, change to block. Let's say block. One signature is selected. Yes, add selected. Click OK. Okay. Activated. We're blocking. I'm not even monitoring. I just want to see if it blocks traffic or not. All right. So let's generate some brute force attempts. Right. 5. You see? I got blocked. I no longer can even brute force to this machine. So if we have a look at the logs, it's going to actually generate some alerts here specifically. That security events maybe take some time. We have to give it some time. Let's go back to the forward. Ah, perfect. See? Deny. And when you see UTM blocked, it means that the advanced feature, the next generation feature of the firewall actually blocked the traffic. So if you click on the log here, you'll see the time. Don't ignore the time because it's not configured properly, I think. It's 6 p.m. evening here. That's my IP address, my public IP address. The port number, RDP. It's all blocked. And if you click on the security, it actually tells you what was the IPS policy that denied the traffic. See, incident serial, and it generated the log that we wanted. You can actually go ahead, if you're a pen tester, if you have some knowledge about pen testing, you can use a Kali Linux and makes it easier for yourself. Like spawn up that Linux machine that we have, install SSH. Like SSH is already installed on that. Just brute force SSH into it, and it's going to generate hundreds of logs to you guys. So let's check if I can access it again, like the VM. Okay, it's good. So it blocks me, and it's going to stop me from brute forcing, and it's like typical IPS. You can tweak it to actually quarantine my IP address completely. So the firewall doesn't even allow anything else after that from my IP address. But that's not going to end up well with me in this case, because if that happens, I'm no longer able to log into this firewall from the public IP address, which is not good. So you see how this works, guys? What I need you to do is to just play around with it. If you have time, go read some about firewalls and FortiGate specifically. You can do a lot of things here. Now, in the next part video, we're going to deploy Sentinel, okay? Log analytics, Sentinel. We're going to send all the logs from this firewall to the SIEM tool. And based on that, we're going to create our own alerting system and perform incident response and all of that. Hope this session was informative for you guys. We're going to see you in the next part, which will be released in the next week. I hope you liked it. Make sure to like this video, subscribe to my channel, share it with everyone else on the internet if you can. Thank you so much for watching. See you in the next one. Cheers.